Starting with the past, let's see. So maybe a little background on how my perspective is formulated in this space is I've been working in data and analytics for about 12 years. So I graduated undergrad in 2009, actually with a degree in industrial engineering. And my first job out of school was doing operations research. So in 2009, as you guys know, the market kind of fell apart. And I took a role with the Department of Defense doing operations research for an agency called the Missile Defense Agency. And I think why potentially this leads into data science is one, honestly, like a lot of things that are modern, our modern things that we use, call it GPS or modern technologies, generally started with in the defense industry. The common problem being in defense, like the soldier's backpack problem. Like we have a survivability rate for each item that a soldier can fit in their backpack. And ultimately we need to create an optimal set of things that a soldier can carry to optimize their survivability. So with that thought process, you can expand that thinking to, a number of things within the DoD, but not only in that space, but also within business. A typical problem of, route planning is solved with a similar heuristic and optimization coding. So, while we had a need for these things that ranged back from a long time ago, we start to see them now creeping into business need, and this has been going on for a good 10 to 15 years. But I just thought I'd put a little background of how I got started. I think, a few of the things that have further enabled data and analytics to expand across the business, I think it originally started with processing power. I think there was quite a lag with the technology to run some of these really powerful algorithms like neural networks and things of that nature, which have been around for decades. We just have never really had the compute power to use these tools effectively. And then, the emergence of machine learning has really improved. And then also the cost of storage. So, the cost of storage has really allowed us to collect a lot more data and store it effectively. Therefore, being able then to process it quickly really allowed for the expansion of data science to expand from, in operations research where potentially like budgets aren't limited, are unlimited, to now where, they make a strong case for ROI to run some of these tools to make business decisions. So, following my career on where I went, because I think it outlines this past story, from the DoD, I went on to a company called Level 3, which was ultimately now part of CenturyLink. But Level 3 Communications is really, I think they own the largest backbone of the internet. So long haul transmission of data. And, I think Level 3, just by nature of who they are, have a ton of data available. So in terms of data and analytics use cases, and this was around 2012, 2013, it was great. My title at the time was a quant or a quantitative analyst, because the term data science still wasn't really coined, at least as a job title. So, some of the things we were doing was around using data and analytics to ultimately improve business decisions, as I mentioned. And we had a very novel use case. And I'll describe it because I think it talks, it gives you an idea of like where things were at the time. So in 2012, Python wasn't, used for data and analytics yet. I was actually using R at the time. And what we were using R for was, so the use case was, we had a product that behaved somewhat as a commodity. It was like a VPN. It was extremely price sensitive because of the nature of the industry. And ultimately what we were looking to do was disrupt from a pricing standpoint. So in order to do that, the first thing we thought to do was measure demand in the market. So how could we go do this at a customer by customer basis? And we started down this path by first looking at what data we collect to be able to answer this problem. And it came in a structured form, which was for every bid that our sales teams gave to a customer, which consisted of a quote, we were able to record that information, even if it was just in a PDF. So, for example, I'm a salesperson. I'm selling you a VPN private, or a private line. I gave you a quote for $600. You declined. I gave you a quote for $500. You declined. But then I gave you a quote for $300 and you accepted. So collecting information like this at a broader scale across thousands of salespeople and hundreds of thousands of customers, you can really start to find like pretty strong elasticity curves. And we were also collecting information about the customer, like location, type of business, types of employees, and all those fun things that would ultimately be fed into a model. So what we were able to do with that info is, at the time, we were just running a logistic regression, but we were able to, plug that information into a logistic regression and better understand what the impacts of a type of customer, say for example, is this a law firm versus a major corporation? What is their impact on their price sensitivity? Because some of the idea behind price economics is that, like, if your price is too low, you're leaving money on the table. If your price is too high, you're leaving wins on the table. So you're really just trying to find the peak of the curve ultimately to optimize your win rate, but also maximize your margin. And with the data we collected in the result of that logistic regression, we were able to plug the results into a nonlinear program to which we could ultimately hit run and optimize for whatever objective we are shooting for. So, and the reason why I talk about this use case is that these tools have been around for a while. And I also want to note, like, the path of measuring using the logistic regression and optimizing is still seen today in the models. It's just different techniques. And honestly, from the logistic regression and nonlinear program, those are still around. It was just, kind of the archaic version. But what we found is this method actually did a lot of disruption, because we were able to measure very, very minute changes in the market. For example, if a competitor of ours were to change their rate, we would see a dip in our win rate, ultimately indicating that something has changed in the market, because we assume that most people would be shopping around given the commodity nature of these products. So, when I think of past data science, I combine my experience, which lies in fields that actually at the time weren't called data science. And they were around, doing operations, optimizing business decisions, whether it's operations or sales functions, like same problems, but just, honestly rebranded, a little bit different technology. I think it's become a lot easier. I think the entry to getting into this space is a lot easier, just given how readily available some of this educational material is for some of the more junior folks. But, I think, so while level 3 was, I think, potentially, in line with the curve, the next steps in my career were talking about still some of the past, but getting into the future, which was, I moved into consulting after I left level 3, and I spent 4.5 years in consulting, 3 of which at Accenture, where I had some pretty large clients, including Google, Molson Coors, and a few others. But ultimately, similar thought processes. I wasn't necessarily helping them build products, but helping them just make better business decisions. And I think, what I learned primarily there, and I think this is still one of the significant challenges, is the human element when you have this decision process, and whether it's as a product or as a service, or you're just building business analytics that are used internally, there's still a human element involved in data science. So how that applies is, if I'm doing business analytics and I'm trying to convince someone to do their job differently or make a decision with some analytical models, not only does the model have to check out from, a logic standpoint and be accurate, like there's other things like such as change management and how do you ultimately incentivize people to do what you want. So it kind of is getting into like thinking about a model's performance, not necessarily as an accuracy as an F1 score, but more of the bigger picture of like, what can people get from this and what value can a company obtain from this model? So as I grew as an individual in my career, I went from someone who was thinking like, hey, being good at my job is getting the best model fitting to, how can I start to think about like having a great model is nice to have, but like at the end of the day, a great model that doesn't get anyone value is worthless. And I think honestly, while that issue was, that was 3 to 5 years ago, I think a lot of companies still get hung up at that point is how do you, and whether it's buying analytics tools and getting value from them or ultimately, building them internally and how do you structure the right organization and all those fun topics that come with, building any team internally. So to the present, where I am now, I work for a company called Vertafore. I lead a team of data scientists, and I'm still very hands-on. I think any data science leader should be that way. But I think the problems that I'm facing now, because I'm leading a team, is a lot of people problems, like how to hire the right data science teams, especially with the changing technology stacks. Like I think, as I mentioned, in the present tense, when you come onto a data science team, they ask you to like, hey, build the roadmap, build the technology stack, and then ultimately hire. Those are generally the first few things when you start a team from scratch. And I'll touch on each of them. I think from a technology standpoint, generally it's relatively straightforward and things are done in the cloud. You have a cloud provider and ultimately it kind of leads to using one stack or the other, whether it's Google Cloud, Azure, AWS, et cetera. And, in that regard, they've made things very easy to do a lot of things, whether that's, building machine learning, deploying machine learning into products, and ultimately just doing testing. They've slowly automated some of these like pretty time-consuming functions that would go on within the data science process. So I will say the role of the data science is changing. It changed from building things from scratch to starting to use more productized features. And I think really it depends on where you are in that spectrum based upon your budget, your analytics maturity, and all the fun things in between. But all in all, where I see the present day trends is that I think the open source nature of some of the big players such as Facebook, Google, where they, on a regular basis are producing pretty groundbreaking data science algorithms. And while, the layman or while like a company that doesn't compete in that space doesn't necessarily have the data nor the computing power to ever like fully utilize those models, I just think seeing it is great. Like I feel like, I always had like thought and hypothesized which is going to be the laggard, the data, the use cases, or the algorithms, or really the compute power. And, and I think if I had the answer to that question, I probably wouldn't be here. I'd be making a lot of money and but it's a good thing to think about, and I think it maybe leads to some of the future conversation when I get there. But I think another thing to talk about in the present tense is just the hiring aspect of how do you building the data science team and how, in theory, that plays into space where now you have students with boot camps, you have students coming out of master's degrees of data science. Like these things weren't around 5 to 10 years ago, so it's creating a new workforce of folks that have experience with data science coming out of college. And while I can't speak for most, for all of these programs, I have spent, I've worked with students from a number of them, and I've found some better than others. But I think some of the key challenges that I will maybe recommend for some of the younger listeners is enterprise data is a challenge. And I think sometimes, like any data science project, 90% of the time is spent on data. And I think sometimes when you're coming out of a data science program, like that may be overlooked and potential expectations may be a little bit off. So I always try to, when I'm hiring, I try to make sure that's very transparent, is that we have, big messy data that needs wrangled. And, most of our time is just spent doing that. And like most things, to me, I would like to see where the future goes with the data cleaning and, ultimately tying data directly to business cases. So in terms of the future, like I said, I wish I knew. I think I hypothesized earlier in the conversation around where's the laggard going to come from? And I personally, and again, maybe completely incorrect, but I think at some point, like we're going to struggle with just data collection. I think, when I was at Accenture, I think we always would try to come up with new use cases, and that seemed to be somewhat of a limiting factor. Like if you're trying to get ahead as a company and create some kind of differentiation, like what's a new data-driven use case that I can come up with that my competitors aren't doing. And at the foundation of these use cases are really unique data sets, right? Is that like, how can I acquire a unique data set or combine data in unique ways so that I have a competitive advantage? So like in theory, if I have a data set that no one else has, like, I can do a lot with it regardless of the models on top, even if it's just reporting in BI on top of a new data set that no one else has. To me, that's an advantage. So I think at the end of the day, that to me is going to be one of the laggards. I do think as machine learning becomes more powerful, I think the philosophy and ultimately the ethics behind, and we're seeing that now, but I would like to see that play a bigger role and be a little more transparent because I know, yeah, I just it's one of those things that it keeps me up at night. So, and partially I read a book by Nick Bostrom on that topic, and he's a leading AI philosopher, and it's a book I'd recommend for everyone. But he gets somewhat doomsday-ish, where talking about like, hey, if we have an optimization function to make a computer make people happy, like what stops them from making people smile in inappropriate ways or whatever that is. So it's just making sure that like we fully understand the problem and then ultimately fully understand how the algorithm gets there. And it's just some of these black box models aren't necessarily transparent in how that's done. I think the role of the data science, I think, the data scientist is going to be changing. That's something I wish I had a magnifying glass for, so that I could better understand how it's going to change in the future. I think, as things become more automated, ultimately we're going to see the role of the data scientist becoming more just managing solutions rather than potentially, at least for the everyday data scientist, that they won't be, hands on keyboard potentially, and they'll just be more, managing bigger picture tools. In terms of where I think data can help in terms of business use cases, I think people, when they think about the future, they think of potentially blue collar jobs being, automated by machines. And while I think that's true, I actually would think the bigger threat is actually like repetitive white collar jobs. I find that things that are can be, with someone just at a computer, like it allows things a little easier entry for folks to be working at, like, for example, data entry. I know there's in the last 5 years, there's been very significant strides in terms of just OCR and abstraction of information from documents, where that used to be a hard problem to solve. It's now something where you can just go purchase an API and pay a cent per page or less to have this done. And immediately the economics become like, if I'm paying someone to do data entry, like these APIs are now outworking them pretty quickly. So I think some of these, like I mentioned, the white collar desktop jobs that I think are highly repetitive are going to face a lot of pressure from AI in terms of what can be done. Um, you know, I personally don't work in the image space, but there was a model that came out. I wish I could remember the name of it, but it was literally like, I had always had like the question I always had was, when is AI going to be able to write a best-selling novel, right? Because thinking of all that, what goes into a best-selling novel in terms of the creativity, it's like, can a machine ever do that? Yeah, I know they can repeat things, but can they ever truly create something that is like original? And there was a model that came out recently that was like literally painting pictures that I was like very impressed with, that were like really original. So while I thought that was originally far in the future, it may be a little closer than what we foresee. And again, it's sky's the limit, right? So these breakthrough technologies, they come through every few years. It's hard to predict them, but I think another one, which you follow these consulting hype cycles, is quantum computing, and while it has a lot of potential, and I'm sure they've already reaped some of the benefits, that in my mind, in theory, has the potential to solve some of these really complex problems that we aren't able to, just by like the manual compute. I think it opens up a lot of doors to like look at a lot of these more bigger problems in nature and in economics that we could really make a pretty large impact on. And again, that being a more technological constraint rather than like data science. But I think it's more just heavy compute power that could potentially drive some of these more powerful models. So I'd like to recommend a book that actually was recommended to me by a former colleague. It's called Gödel, Escher, and Bach: an internal golden braid. And the idea is, that how the music of Bach, the artwork of Escher, and the mathematics of Gödel were ultimately connected in a lot of ways. And I think while it's not directly related to AI, it does talk about some of the prospects, but at the same time, like, I personally enjoy seeing an outsider's perspective and how things can relate to AI indirectly. And I think this book does a great job at doing that. In terms of blogs or websites that I follow on a regular basis, I follow, I spend my time on Stack Overflow. So I think a lot of the more technical folks can relate to that. And I find that I don't necessarily do a ton of reading on the internet just for pleasure. I usually have a question that I need an answer for. So it's my answer machine.